All right, this is the newest video, topic 3 for trigonometry here. And what we're going to look at is trig functions of real numbers. So the first thing we're going to talk about here is, we're talking about functions now. Okay, so we really want to define these trig ideas as functions. You have to remember the definition of a function is that every input has exactly one output. Okay, so we have to understand what we're talking about in terms of trig functions. So let's set up a function, and we use this f of x. Here comes a function with x, and we want this to be sine of x. Let's spend today focusing on sine of x. Okay, now what does the sine function do? The sine function takes in angles. Okay, and remember, it could take in any angle, 0 all the way to 2,000, 3,000, 4,000, infinity. It could take in any angle. It just keeps looping around the unit circle. And it can even take in negative angles. We just got to go in the negative direction. So it can take in negative 30 degrees, negative 60 degrees, negative 9 degrees, and so forth. And it spits out at us the y-coordinate from unit circle. That's what spits out at us. Or you could think of it as it spits out, the ratio in a triangle of the y divided by the r. Okay? That's the y divided by the radius. So now, before we move on to talk a little bit more about all that, let's just kind of review what we're talking about here. Functions have inputs and they have outputs. So if we're going to define sine as a function, its input could be an angle. Now, I'm putting an x here, but remember, an input could be any letter. Could be t, could be theta even, or obviously the typical input value that we use is x. So sine of an angle, so that x represents angles. The domain would be all angles, because that is the input. The domain represents the input for a function. So it's the input, all angles, negative infinity to infinity, okay? And the range is the output. The output would be the y-coordinate from the unit circle, or this ratio y over r, or you can even think of it as a unit or as a triangle and think of old school. Just think of the opposite divided by the hypotenuse. Now, we've talked several times in class that y-coordinate from the unit circle, the ratio of y divided by r, or the ratio of opposite divided by hypotenuse, is always from -1 to 1. Okay, or equal to those values. So the range is any number as an interval, -1 to +1. Okay, and I'm actually a little bit wrong on that. These should be brackets because it could be -1, it could be +1. Now, again, remember that's because in this scenario right here, the hypotenuse is always bigger than any opposite side out there in a right triangle. So you're always going to get a number that's less than 1 or greater than -1. Here, the radius is always going to be bigger than the y-coordinate. And when you're on the unit circle, again, your radius is 1. So that y-coordinate is always going to be from -1 to 1. We've talked about that. So let's kind of really understand this, again, by looking at a couple graphs here that we've seen before. So remember, when we have an angle theta, and this is the angle right here, okay, there's the angle theta, and that angle is going to determine where we stop. And where we stop is a point, x, comma, y, and the sine would be the y divided by that r. So the sine, I know you can't see it right here, but the sine of that angle would be the y divided by the r. Now when we're on the unit circle, it's the same thing. Here's that angle, and the y-coordinate divided by 1 would be sine. So that's why in the unit circle, sine of the angle is just y. Now I want you to understand that this ratio of y over r is the same thing as just y. That's because the angle doesn't care how long the radius is. So let's kind of take a brief little sidestep here. If we're talking about a 30-degree angle with a radius of 5, or a 30-degree angle with a radius of 1, hence the unit circle, right? Now, we know this very well. We know that if the hypotenuse is 1, then this opposite side is going to be a half, because it's always half of that. And this is going to be radical 3 times the 1/2, or radical 3 over 2. In fact, we noticed this on the unit circle. At 30 degrees, the y-coordinate is 1/2, and the x-coordinate is radical 3 over 2. If you don't believe me, look on your unit circle right now, and you'll see that. And that comes from our understanding of this. Now, think about this real quick. If this is 5, and this is going to be 5/2, or half of the hypotenuse. And then the side across from the 60 is going to be 5/2 times radical 3. Now, if I take sine of 30 degrees, that's going to be the opposite side, 5/2, divided by the radius, 5. So that's going to be 5/2 times the reciprocal, 1/5. The reciprocal 5 is 1/5. So the 5's cancel, and you get 1/2. So my point is, whether your radius is 5 or your radius is 1, when you do sine opposite over hypotenuse, y over r, you're going to get 1/2. It's just a matter of, does it need to be reduced or not reduced, okay? So my point is that r doesn't matter. The sine of an angle is equal to the y-coordinate from the unit circle. If your radius is bigger than 1, it's still going to be that same sine value. So hopefully that makes sense. So what we want to look at now is, as this angle's changing, remember the angle is our input. As the angle is changing, what is the sine value becoming? Okay, so let's take a look at some examples here. Okay, so in this first picture right here, we notice that at 7 degrees, so at 7 degrees, so that is our input. Our input would be 7 degrees. Sine of 7 degrees, if you don't believe me, you can use your calculator. 7 degrees is not on our unit circle, so we have to use the calculator. Make sure you're in degree mode. We get a sine value of 0.11. Okay? 7 degrees would be a sine value of 0.11. If we increase to 30 degrees, so if we look at 30 degrees, then we have a sine of 30 degrees. We all know this from our unit circles. 30 degrees is our unit circle. We get 0.5, or 1/2. Okay? So remember, input, that's the x, that's the angle. Output is the ratio of y over r, or just the y-coordinate from the unit circle. So let's continue to rotate more around the circle here. As we rotate more, we get to 60 degrees. So at 60 degrees input, sine of 60 degrees is, remember, radical 3 over 2, which is approximately 0.87. Again, we're just approximating here. When we go all, I know it's hard to see here, but when we go all the way to 90 degrees, when we go all the way to 90 degrees, so when our input is 90 degrees, sine actually reaches its absolute max value of 1. Sine of 90 degrees, the y-coordinate on the unit circle is 1. Then we continue to rotate into the second quadrant. Sorry, we're moving the wrong way here. As we rotate into the second quadrant, we'll notice that, again, when we're in the second quadrant right here, say 131 degrees, okay? 131 degrees, we notice that the sine value is still positive. It'd be 0.75. As we rotate even more, here's 168 degrees. So as we rotate 168 degrees, our sine value is 0.20. So we're continuing to rotate around the unit circle, and we're just analyzing what is the sine function doing as the angle gets bigger. Now, we can continue to rotate. Now, remember, the sine is the y value, right? So I just want you to notice here, again, I tried to show this picture so you can understand. As we rotate into the third quadrant, it's not a very nice straight line, to this angle right here, some angle in the third quadrant, notice the y value is going to now be negative. It's going to be fairly small. As we continue to rotate, that y value is still going to be negative, but it's going to be bigger. Continue to rotate, continue to rotate, continue to rotate. So the angle is getting bigger and bigger and bigger, and sine is getting bigger and bigger and bigger, but more and more negative, actually, because we're in that third quadrant. And then at 270 degrees, straight down, sorry that my pictures, I have a hard time drawing a straight line here, 270 degrees, we have rotated to the lowest sine will ever be, -1. Then we rotate into the fourth quadrant, and we come to this angle here, and notice that sine is starting to increase. It's starting to get more and more positive. Now, you may say, wait a minute, no, it's decreasing. Yeah, I know, but it's negative and it's going up. So remember, this is the lowest it's ever going to be, right down here at -1. And then we start to get smaller or closer to 0, which means bigger, if you think about it that way. So that's what's happening to sine. So you have to remember here that this is a function. Sine is a function, okay? Inputs are the x's. That's an angle. So this is the x values. Those are angles, right? The outputs, which we typically call y, are the y coordinate from the unit circle, right? The y coordinate. So it's not just any y value, it's the y coordinate. So as we rotate around, think about what that y coordinate's doing. So y coordinate, right? When we first start off, y coordinate is very small. Then we start rotating, y coordinate getting bigger, getting bigger, getting bigger, getting bigger, reaches its max at 1. As we continue to rotate, now it's getting smaller, 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 until at 180 degrees it actually reaches 0. Then as we continue to rotate, the y value gets smaller, more negative, more negative, more negative, more negative, more negative, more negative, until it reaches its lowest point of -1. And we're going to continue to rotate. We're going to continue to rotate, and now we get more positive, a little bit 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 more positive, until we reach 360 degrees and we reach back to 0, a sine value of 0. And then guess what? The whole process starts to repeat itself. So then sine starts at 0. It gets bigger, 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 reaches its max of 1, smaller, 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 more negative, more negative, more negative, more negative, more negative, more negative, all the way at the most negative it'll ever be, -1, and then it starts to make its way back up. And then it does the whole thing over again. We call this a circular function. Okay, because what's happening here is as the angle is getting bigger and bigger, more rotations, a third rotation, a fourth rotation, the y values, the outputs are just repeating themselves. So remember, the x could be anything at once. It's an angle. I can continue to rotate and make that angle really, really big. But the outputs, the y coordinates from the unit circle, just repeat themselves as you go around more and more and more. So this picture actually starts to look at what the sine function looks like, okay? So let's remember that the x coordinate here, the x-axis, is the inputs, which are angles, theta, right? Angles. The output is the y coordinate, or the y-axis, which is the y coordinate from the unit circle. So at 0 degrees, the sine value, look on your unit circle by the way, is 0. So I start right here. Then as I rotate, so let's say we rotate 29 degrees, right? If we rotate 29 degrees. So if you want to use your calculator, just make sure you're in degree mode. Sine of 29 degrees is about 0.48. So about 0.48. So it's hard to show it exactly, but close to a half, right? So let's say again that this is 1 right here. So let's say this is the max of 1, right? Okay, so then I rotate to 75 degrees. So sine of 75 degrees is 0.97. It's just almost 1 right here, almost 1, right? Then I get to 133 degrees. So sine of 133 degrees, I've now gone past my max, because remember 90 degrees it reaches 1. I've gone past my max. Now I'm on my way back down, because that's what's happening. Again, remember that unit circle. As you start here, sine values slowly increase, 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 increase. And then once you reach that max of 1 at 90 degrees, here that is, then you start to go back down towards the negatives. So here's that value coming back down towards the negatives. Then at 173 degrees, I'm almost at 180. Sine of 173 degrees is about 0.12. So it's very, very small right here. Then at 180 degrees, I reach 0. Remember, sine of 180 degrees is 0. So here's my rotation. I've started at 0. My y value gets higher, 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 higher. And then I reach 90 degrees, and it's at its max of 1. And then it starts to go back down. Now, what continues to happen? Well, here we go, right? Then, as I rotate more around that unit circle, so my y values got bigger, 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 reached that max, went low, 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 low. Now they're going to start dipping into the negative y values, because in quadrant 3 you're negative, right? So here they are. They're starting to go down to the negatives. So for example, sine of 222 degrees, I'm at negative 0.67. Okay, and then I'm going to continue to rotate, and let's go to, let's say, 353 degrees. So sine of 353 degrees, I'm at negative 1.12, so I'm almost back to 0. And then finally at 360 degrees, I have rotated all the way back to 0. So this is what the sine curve looks like, and it really should make sense. Starting at 0, as my angle gets bigger, because remember, now I'm actually talking about a function where the x-axis represents what the x values are, what the inputs are. Those are angles. So at 90 degrees right here, 90 degrees, I have reached my max value of 1. Then as the angle gets bigger and bigger, I get to 180 degrees. 180 degrees, my y-coordinate goes to 0. And then, as I continue to rotate more, I now dip into the negatives. And then I go all the way down until I reach 270 degrees. That would be right here. That would be my minimum at -1. And then I start my incline back up. As we get closer to 360, I get back to the sine value of 0. And then as the angle continues to get bigger from them, 361 degrees, 370 degrees, 380 degrees, the whole process repeats itself. So we start this curve like this. It just continues to repeat itself. Okay? That is the sine curve. So here's a nice picture of what that sine curve is going to look like. Starts at 0, 0, and as the values change, all right, as the angles go on, remember the x-axis here, these are angles, okay, and the angles can go on forever. Any angle could be plugged in, but the y-coordinate hits its max at 1, at 90 degrees, or, ooh, this is in radians now, remember, okay, because we can measure in radians. So in radians, 90 degrees right here would be pi over 2. Pi over 2 is approximately 1.57 radians. So we reach our max of 1, and then we start to decrease as we rotate to the second quadrant. Sine continues to decrease until we get to pi radians, right, which would be about 1 or 3.14, okay? And then that's when we're at 0, and then we continue to start the whole process over again. All right, so sine is this circular function where as we continue to analyze the angle and the y-coordinate from the unit circle, we see this nice rotation here, okay? Now I also wanted to show you the unit circle, so once again you can see this, right? As the angle increases 30 degrees, look, it's at 1/2. Then at 45 degrees, it's at radical 2 over 2, slightly bigger than 1/2. Pi over 3 or 60 degrees, radical 3 over 2. So it continues to change, right? So the input is an angle, whether it be degrees or radians. As that angle changes, the y-coordinates increase, hit the max of 1. Then they decrease, hit 0. And then they start to dip down into the negatives until it reaches its absolute min, -1. And then we continue to surge back up towards 0. And then the whole process starts over again. So it's this nice continual up, hit a max, down, hit a min, back to 0. And then repeat. Up, hit a max, back to 0, down to the min, hit back to your 0. So it's this nice continuous curve here. And again, it's pretty crappy looking, but you get the basic idea of what the sine function is doing. Okay? So we like to emphasize what we call the critical values, okay, the critical points. The critical points are known as the quadrantal points. So at 0 radians, my sine value is 0. At pi over 2 radians, I'm at my max of 1. At pi radians, I'm back to 0. At 3 pi over 2 radians, I'm reached my min at -1. And a full circle, 2 pi, I'm back to 0. So here we go. Ready? When we think about this, here it is, right here. Ready? 0, reach that pi over 2 or 90 degrees. I've hit my max at 1. Start to come back down to 0 at 180 degrees. I'm to 0 or pi radians. Then I continue to get lower and lower and lower until I reach that 3 pi over 2 or 270 degrees, and I reach my min at -1. And then I continued to increase my angle, and my sine value goes back to 0 at 360 or 2 pi. We like to use radians a lot, to be honest with you. We just really do. So we got 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. This nice, smooth curve is created. These are our 5 critical points. And then you start to rotate again, and the same pattern starts to occur. The same pattern. If you go backwards, negative, then you go down to -1 first, back to 0, up to 1, back to 0. So it's that same pattern, just in the negative direction. All right? So hopefully that makes sense. We'll talk a lot more in class about that, but hopefully you get the gist of what the sine function is doing. And later on, we'll talk about what the cosine function looks like, and even tangent.